Well, howdy there, Internet students. It's Mr. Hermanson again. Say we're working on 6.2 D, and this is day 2. I think today I'm just going to help you with some of your homework problems. So let's go to page, I think it's 28. I'm going to do one that you did on your homework that you might not have gotten correct, so we'll just check that. I'll do number 16 with you, and then I'll do a couple from your assignment for today. But we want to know if these are parallel, perpendicular, or neither. If they're parallel, that means the slopes will be the same. So we'll take a little note here. Same slopes. And if they're perpendicular, they would have opposite reciprocal slopes. So one thing students forget is that they need to be opposite reciprocals. So here's an example, like negative 2/3 and 3/2. All right, so we can see in this first top equation here is written in point slope form, and the slope is 3. On the bottom equation, we can't tell the slope because it is written in standard form. So we're going to change that to slope-intercept form by solving for y. So I'm going to subtract 2x from both sides. That gives me 6y equals negative 2x plus 10. Then I'm going to divide everything by 6. And now it's y equals, I'm going to simplify negative 2/6, that's the same as negative 1/3, x plus, and 10/6 simplifies to 5/3. So now I can see the slope here is negative 1/3, the slope here is 3. Those are opposite reciprocals. Now if you get decimal numbers or you forget, remember that if you multiply opposite reciprocals, they'll equal -1. So if 3 times negative 1/3 equals -1, that's a way to check to see if they're opposite reciprocals. And I think they do. All right. On your assignment for today, I just wanted to do a couple with you, get you going on these. For number 20, it says write an equation in slope-intercept form for the line that passes through the given point and is perpendicular. So you want to look at this slope here in this equation, which is 1/2. To be perpendicular, you need the opposite reciprocal. So we're going to flip that over. Since 1/2 is positive, we want this to be negative. And I'm going to just simplify that to -2. Okay, now we want it in slope-intercept form. If you're good at doing that, then do it the way you like to do it. But what I'm going to do is use point-slope form because I think it's easier for most since we're given a point. So I'm going to write y minus 3 equals -2 times the quantity x minus -2, which is x plus 2, if I simplify that. Then I'm just going to get rid of the parentheses here. I'm going to multiply -2 times x and -2 times 2. And then I'm going to add 3 to both sides, and I'll have my equation. Okay, so if I add 3 to this side, I get y, which is what I want. If I add 3 over here to this -4, I get -1. So -2x minus 1 is my answer in slope-intercept form. All right. The other thing I thought I'd do for you, with you, is this geometry problem. And I think it would not hurt for me to graph that. So I'm going to make a graph. There are some negatives, so I think I can just go to 5. All right. All right, here's what it looks like when you graph it. Now we want to know if it's a right triangle. That means that there's some right angle in there. It doesn't really look like it, but the way you would prove that is by finding the slopes. And if you have any slopes that are opposite reciprocals, then you know those two sides form a right angle. So I'll just do this one with you here. We need to go up 2 and over 4. So this slope is 2/4 or 1/2. Now, if either of the adjacent sides of this triangle had a slope of 2, then of -2 actually, then you would say that it's a right triangle. Okay, so I'll let you find the slopes of the other two sides, and then just look at them and see if any of the slopes are opposite reciprocals for adjacent sides. All right, well, that's all I got for you today. So if you have any questions, make sure you message me. Otherwise, have a good day, and we'll see you soon.